Yes. So code optimization in compiler design. It is very important part of the compiler design now because it is newly added subject, newly added topics in the GATE 2021 onwards. So don't worry if they ask 1 to 2 marks question, you can easily grasp it, right? So let's discuss the definition point of view. The code optimization in the synthesis phase is a program transformation technique which tries to improve the intermediate code by making it consume fewer resources, that is CPU and memory, so that faster running machine code will result. So in code optimizations, that will be go in the synthesis phase, and in that program transformation technique will be there, which will try to improve the intermediate code by making it consume fewer resources. Means suppose your CPU will consuming more memory earlier, then what we need to do, we need to reduce the programming, we need to reduce the lines of program such that it can consume less portion of the CPU and less memory, so that faster running of the machine code will be there. Means we just need to increase performance. All thing up in code optimization is because of performance. Means ultimately we just want to increase the efficiency of code. We just need to want to increase efficiency of code. It is our target, it is our main target of code optimization. In code optimization we just need to increase the efficiency of code. Okay. Now, if we talk about compiler optimizing process, then the compiler optimizing process should meet the following objectives. What are those following objectives? The optimization must be correct. Whatever optimization we will do, it should be correct according to the rule. It must not in any way change the meaning of the program. Means whatever optimization we will do, it should be correct, and it should not change the meaning of program. We should need to take in our mind, we just need to focus on our mind that we can do optimization, it is okay, but it should not change the meaning of program, because if it will change the meaning of program, it is not correct optimization, it will be considered as an incorrect optimization, right? That is why our optimization will also be correct, should always be correct. Now the next one is optimization should increase the speed and performance of the program. Optimization, the basic goal of optimization is that it should increase the speed and performance of the program, because if your speed and performance of program is not increases, not level up, then you can't say that you have done any optimization. Optimization itself means that performance or the efficiency somewhat increases. The next one is the compilation time must be kept reasonable. Means it should be reasonable, it should not take so much long that user is not ready to wait. It should be reasonable so that user can wait up to that time and result can be in front of their screen. So it should be kept reasonable. The next one is the optimization process should not delay the overall compiling process. So overall compiling process should also not be delayed by optimization. Optimization should be carried out in nanoseconds. Basically in practical, if you will try to run any program, it should done in nanoseconds. So users don't get any idea that whether he is write high level code and all the processes of parsing tree, tokens, syntax tree, semantic tree, synthesis, intermediate code generation, and code optimization happen. All these processes happen in just nanoseconds, and it get output on the screen. So it should be overall kept, it should not get delay, right? It should be kept reasonable so that user can get all the user can get its output on the screen on a reasonable time, right? So it is the basic definition point of view for the code optimization. If you guys are noting down this definition and points, important points, you can note that, or you can also take a screenshot of it, guys, no problem. You can also take a screenshot of it so that you can kept it on yourself, and whenever you will gonna revise this topic, you can get knowledge of it, right? Now I am going to next slide. The question is when to optimize. The very important question, that optimization, okay, it is okay that we need to optimize, but when to optimize, it is again very important question, that when to optimize. So the answer is optimization of the code is often performed at the end of the development stage. So whenever our code is developed completely, whenever we are ready with the execution statement, means our code is completely ready, means at the end of our development state, since it reduces the readability and adds a code that is used to increase the performance. That is why optimization is carried out at the end of development state. So you may face, guys, you may face a question, you may get may ask directly question from you that when should optimization be carried out, and it may give you four options. So you must have the knowledge that optimization should be carried out or performed at the end stage of development, because it ultimately reduces the readability of code and add some code that increases its efficiency. That is why it need to be optimized at the end of development state. So at this point may be asked is a point of theoretical question in GATE, right? So you must have to take this kind of topic, this kind of points with you, or you can simply take a screenshot, no problem. But you should need to understand complete logic behind each statement, because there is a very great logics behind each and every statement which I have included in this portion, and every statement gonna help you. Every statement is a part of very important MCQ, and GATE and other exam can ask directly this kind of question. So you just need to mark this question and statements. Now, why optimize? So for this, we can say optimizing an algorithm is beyond the scope of code optimization phase. So the program is optimized, and it may involve reducing the size of code. So optimization helps to reduce the space consumed and increases the speed of compilation. So why optimize? Because suppose there are billions of lines of codes in any program. Suppose there are billions lines of code in any program, billion lines of code in any program. So there is a great need that the lines which are dead lines, lines that are not of use, lines which are unnecessarily used, or unnecessarily comments or unnecessarily coding which we have written in our program, which is not a part of our project, which should always be removed, so that our space consume should be, means our space can be more, means we can save the space in the memory, and we can overall increase the speed of compilation, we can overall increase the speed of compilation. That is why optimization is needed, to increase the efficiency of our code. Now, manually analyzing data sets involving a lot of time. So basically, if we will manually go in analyzing the data sets, it will take a lot of time. Hence we make use of softwares like Tableau for data analysis. If you are good on R or Python, or if you are learning machine learning, then I hope you learn the Tableau or data analysis, because if you are preparing for data scientist post for any MNCs or like any startup, because data scientist posts are very in demand as of now. So Tableau is a very important technology. So if you are using software like Tableau for data analysis, similarly manual performing for the optimization is also tedious, and it is better to done using code optimizer. So guys, you can simply say that using Tableau you can optimize code, or similarly like these softwares you can directly use code optimizer and reduce the lines of codes in your program. Okay, so yes, Abhishek, it is true. So an optimized code often promotes reusability, because optimized code will promote reusability. Suppose a line of code is there that A equals to B into C, and further if we need the multiplication of B and C in later phases, suppose further in the later phases there is a great need of B into C, then we will not write B into C again and again and again. We will reuse this A. Whenever we need the result of B into C, we will take A, and we will consider the result of B into C directly from A. So an optimized code often promotes reusability. Very important point, guys. So take a screenshot of it and I can proceed for the next one. Please take a screenshot of this slide. Yes, Ashik, there is a great difference. There is a great difference between the post of analyst. Data analyst is a separate post, and data scientist it is separate post. Both posts are in demands, and you can Google it on you can Google it basically. But both data analyst phase is a data analyst post is separate, and data scientist post is separate. Okay, guys. The next one is types of code optimization. Now we are discussing types of code optimization. So the optimization process can be broadly classified into two types. On in the very first slide, when we have discussed the phases of compiler design. At that time also I have mentioned in very detailed that we have two types of code optimization. The very first one is machine independent optimization and the second one is machine dependent optimization. In the earliest slide, in the first slide, when we have started the first session of our compiler design, I have discussed in detail that there is a there are two types of optimization in code optimization, that is machine independent optimization and machine dependent optimization, right? So in machine independent optimization, if we talk, this code optimization phase attempts to improve the intermediate code to get a better target code as an output. So whatever we get as an intermediate code generation, from intermediate code generation phase, what we get intermediate code. So to make that intermediate code as a better target code, means better machine relocatable code, we as a output, right? So the code optimization attempt to improve the intermediate code generation to better target code as output. The part of the intermediate code which is transformed here does not involve any CPU registers or absolute memory location. So in machine independent optimization, the transformed code, that is intermediate code transformed, will not involve in CPU registers, will not involve any CPU registers or absolute memory locations, right? In machine independent, because these codes are independent on machines, whether you use Linux, Windows, or like that, right? Now the next one is machine dependent optimization. In machine dependent optimization, if we talk, machine dependent optimization is done after the target code has been generated. Means if target code is generated, after target code, machine dependent optimization is done, and when the code is transformed according to the target machine architecture, that is in machine codes or machine relocatable code, it involves CPU registers and may have absolute memory references rather than relative references, right? So CPU registers and absolute memory references may have a part in target code, may have a part in machine dependent optimization, but in machine independent optimization, CPU register and absolute memory locations will not involved. And machine dependent optimizers put efforts to take maximum advantage of the memory hierarchy, so that they can reduce the they can basically increase the efficiency ultimately, because optimization is all about efficiency. Okay, so these are the two types of the code optimization. And now we are moving to the code optimization is how code optimization is done. So code optimization is done basically in many ways, and one by one we are going to discuss, right? So guys, before that you need to take a break of 5 minutes so that we can discuss these slides with complete relax, right? So do you need 5 minute break, guys? Now let us focus now on code optimization is done in the following different ways, right? So there are various ways in which code optimization is done. The very first one is compile time evaluation. So what compile time evaluation is, if you will take example, suppose a equals to 2 multiply with 22.0 divided by 7 into r, then what it will do, it will perform 2 into 22.0 divided by 7 and multiply r at compile time. So this would be perform at compile time, means it will multiply, it will basically evaluate the result of 22 into 22 by 7, then it will multiply it 2, and then it will multiply that whatever the value of r would be. So according using the mathematical rule, it will perform at the compile time. So this is called as compile time evaluation. The next one is, suppose x equals to 12.4 is there and y equals to x divided by 2.3 is given in the program, in the code, in our code, suppose it is writing like that, then it will evaluate x divided by 2.3 first. It will divide x divided by 2.3 first by putting 12.4 as a value on the place of x. So it will put 12.4 on the place of x, and then it will gonna divide it with 2.3, and whatever result will be there would be on the output screen. So it is called as compile time evaluation. Means when you will perform the CTRL plus F9 or F9 is a compile. So whenever you will perform the compilation of your code, at the compile time itself it will get evaluated, right? So it is the first kind of optimization. Means you can say that simply at a compile time evaluation, right? There isn't any kind of existence in the get syllabus for this, but for just knowledge purpose you can take in knowledge that whatever is written or whatever is calculation is there will be done directly on the compile time. Next one is variable propagation, very important but not a part of get, but still we are discussing it. The next one is variable propagation. So what is variable propagation, guys? Suppose before optimization we have the following code, that is c equals to a multiply with b and x equals to a till it is a part of code, and d equals to x multiply with b plus 4. Suppose it is our code, before optimization, before code optimization it is our code. So after optimization, after applying variable propagation, how our code will look like: c equals to a into b, it will be same, and x equals to a, it is again same, till d equals to, on the place of x into b, how it write a into b, because if you will see c equals to a into b is here, that is the first one, and in that x equals to a is given, and then d equals to x multiply with b plus 4 is given. This is our code before optimization. Before optimization it is our code, but after optimization c equals to a into b and x equals to a would be there. So d equals to a into b plus 4 would be there. On the place of this x, they have replaced it with the value of a, right? They have replaced it with the value of a. So this x is get replaced with the value of a. So this x equals to a, this will be considered as a dead statement now. It will be considered as a dead statement now. Why? Because no need of this one. So we will optimize this code as a c equals to a into b and d equals to a into b plus 4, like that. No need to write x here, no need to take any extra variable here, right? No need. So we can write it like that, because x is nothing but the value of a. So it will consider dead statement. It is called as variable propagation method of code optimization. It is called as variable propagation, means we are propagating variable. So on the place of this x, we have put at our variable a. So after variable propagation, a into b and x into b will be identified as a common sub expression. It is considered as a common sub expression. It is also a new topic, and we are going to discuss it with examples itself. So it is common sub expression. Okay guys, now the next type of code optimization is dead code elimination. So dead code elimination is nothing but variable propagation often lead to making assignment statement into dead code. Previously you can say variable propagation makes assignment statement. This is our assignment statement, isn't it? It is our assignment statement, isn't it? Because we are assigning the value of a to x. So on the value of this x, we have put a directly. Now there is no need of x, because we don't have x anymore in the statement in our code. That is why we will consider x equals to a as a dead statement, right? We will consider this as a dead statement, and after elimination of this dead statement, our optimized code will be look like that. It is our optimized code. It is our optimized code. Okay guys, and the next one is code motion. The fourth type of code optimization is code motion, right? So code motion, what it will do, it is very important as a part of programming in IT industry. In IT industry, right? Or if we talk about algorithm and data structure part in IT industry, this code motion performs very important part. This code motion performs very important part, not for the perspective of gate. I am not talking as a perspective of gate, but I am talking about the perspective of IT industry. Because if you guys are looking your career in IT industry, then in real time you will gonna face this problem. What problem I am talking about? Focus here. Code motion, basically if we talk about definition purposes, it reduces the evaluation frequency of expression. It will gonna reduce the evaluation frequency of expression. It will gonna reduce evaluation frequency of expression. How? Focus here. Suppose a code is here that int main, okay, okay, suppose this code is there, this code is given to us, suppose this is our code, okay, and in this code, suppose this while condition is, this while condition is going, is this while condition is suppose running 1 billion times, this while condition is suppose running 1 billion times. So this statement will be this statement should be executed 1 billion times. This statement will, this condition will gonna check 1 billion times, and this printf statement will gonna work for 1 billion times. Why? Because this while condition is working 1 billion times. So to reduce this, to reduce evaluation frequency, what does evaluation frequency? Suppose b equals to x plus y, if we declare it outside of this loop, if we declare this statement outside of the loop, then this statement will only execute one time, and we have reduces our time space, we have reduces the time spaces and consider of time complexity by 1 billion times. So it will reduce our 1 billion times execution just because that this statement was the inner part of that. Now we have put it this statement as a outside, in outside of the while loop. So what it will do, it is nothing but this process is called as loop optimization. This process is called as loop optimization, because by putting this statement b equals to x plus y, we have optimized our code 1 billion times. Now our cpu will get free 1 billion times, because it did not need to assign this x, the value of x plus y to be 1 billion times, because we have put it outside. So such kind of optimization is called as, is put under the code motion, and this process is called as loop optimization. So the second statement is bring loop invariant statement out of the loop. So bring loop invariant statement, this is the b equals to x plus y, b equals to x plus y here, it will be considered as a loop invariant statement, because there isn't any need of this statement to put inside while loop, we can also work by putting it outside, right? So the what is the existence of first statement, it will reduce evaluation frequency of expression. So I hope you are clear with that, that what exactly evaluation frequency of expression means, right? And the next one is it will bring a loop invariant statement out of the loop, it is the existence of it. So this is nothing but it is the code motion, it is called as a code motion. And by optimizing using code motion, we can reduce our programming time by billions of times, because in this kind of code motion, basically code motion is done under the loop things. Because if you are removing any statement, suppose you are removing any line from any program, then it will reduce just one line and it will save just one space of your time. But if you will make out this statement out of the loop, that will save billions of times, right? So this procedure is called as code motion. Code motion is clear to everybody or not, guys? Please comment me in the chat box, is it clear to everybody, guys, that what I have told you under code motion way of code optimization? Is it clear? Because it is a part of IT industry, and whenever you are going to face IT industry interview, you will get such kind of practical problems in front of you, and they will ask that which statement should be put outside of the loop, or what you will modify in the current executable code, so that our code complexity can be reduced, the time complexity of our code can be reduced. What you will apply? So you will need to apply code motion there. Is it clear to everybody, guys? Are you understanding what I am telling to you under optimization techniques? Very good. Very good. It is clear to everybody. Very good, guys. Very good. And the next one is induction variable and strength reducer. Induction variable and strength reduction. It is the fifth way of code optimization. It is the fifth way of code optimization. Let us take the definition. What is definition? An induction variable is used in loop for the following kind of assignment, that is I plus I plus constant, I equals to I plus constant. If we have such kind of assignment operator, then in that assignment we are going to use induction variable and strength reduction. What exactly it is? Strength reduction means replacing the high strength operator by low strength. Strength reduction, very important guys, replacing high strength operator by low strength, it is called as strength reduction. What I am talking about, suppose my code is I equals to 1 while I is less than 10 and y equals to I multiply with 4. Okay, it is suppose my code before optimization. So now I am optimizing this code. So after optimizing this code, I can write it like I equals to 1, t equals to 4, and while t is less than 40, y equals to t, and t equals to t plus 4. So if you will see here, I have reduced this multiplication operator. I have reduced this multiplication operator with this addition operator, because you know the precedence, the strength of this multiplication operator is high and the strength of this addition operator is somewhat low. So if we will also do like things like that if we will replace this multiplication operation with this addition operation, this is called as induction variable and strength reduction. By that optimization will be done. Because you can write whatever functionality this code is doing, this code will also do the same functionality. We just replace this multiplication by taking one another variable, the t is a 4, we have changed the condition by directly t is less than 40, because here also we are multiplying it 4, so we have increased the size of variable here, and by assigning one more new variable as a t, we have make this code looks like this code, it will work same as this one. But here we have what we have do, on the place of this multiplication operator we have put plus, that is addition operator, so it will optimize our code and it will work with better efficiency. Guys, if you want to know me that what is the practical example of this one, then I hope you all know that matrix multiplication by, can you answer me what kind of matrix multiplication you have seen in the data structures and algorithm? In data structures and algorithm, the complexity of matrix multiplication, that is order of n cube, are changed from order of n cube to order of n to the power 2.71 to 2.84, like that. I hope you know about this concept. Do anybody tell me that what I am talking about? Do anybody let me know that what I am talking about? What matrix multiplication I am talking about? Yes, Abhishek. What I am talking about, do you know? In data structures and algorithm, I think all of you have. Very good, Ashik. Very good, Ashik. Ashik had got the point. Stations matrix multiplication. Very good, Ashik. You have got the point. You have catch the point. In stations matrix multiplication, we have reduced the complexity of the matrix multiplication from order of n cube to order of n to the power 2.71, like that, because earlier we have 8 multiplication and 4 addition, but by optimizing this code with stations multiplication, on the place of 8 multiplication we are doing 7 multiplication, but our addition from 4 it is gonna high, that is from addition are increased to 16, but our multiplication are reduced to 7 from 8. So stations matrix multiplication is a live and practical example of induction variable or strength reduction. So all the concepts are basically connected, you just need to catch up it from another subject. Basically all computer science are connected with each other. So I hope you got that what optimization I am talking about. This kind of optimization is called as induction variable or strength reduction, in which we reduce high strength operator with the low strength operator and work on the code so that efficiency of code can be higher. Is it clear to everybody, guys? Arjun is asking, sir, we don't do we need to do this type of reduction manually? Yes, Arjun. You need, basically in IT industry, you need to do it manually. Basically, there are some softwares for code optimization, code optimizer, but but in real time, in real industry, you do not need to do such kind of things. Just while facing interview, just while attempting exams like GATE, ISRO, NET, you just need to do this manually. But while doing in industry, there are so many softwares which will optimize your code, but you need to you need have a knowledge of these bits in your mind, that yeah, what kind of thing can reduce my reduce and create efficiency of my code higher, right? So there are many softwares for both for the purpose of interviews, because in startup interviews like Flipkart and Amazon, you are really getting this kind of codes, and they will ask that how will you reduce the time complexity of this code, how will you change this code so that this code will perform in better time complexity term of you, like that. So in that case, you need to reduce the code by applying this kind of techniques, right? So I hope it is clear to you. Okay, Siddhi is asking, sir, that please tell me second and third method. So second method was variable propagation. In this variable propagation, what we have do, the code here was c equals to a plus b, x equals to a till d equals to x into b plus 4. So on the place of this x what is doing? X is fetching the value of a, and a is already there. So why there isn't any need of x now? We can replace this x with a itself. So it will what it will do? It will just reduce this statement, means it will eliminate this this will x equals to a assignment statement as a dead statement, and our code will be optimized like c equals to a into b and d equals to a into b plus 4, because we have unnecessarily created one more variable with the value of x as a assign operator to a, means x is taking value of a, and then we are assigning value of x to here, but directly we can assign the value of a directly to here as well. So this is called as variable propagation, in which we are playing with variables, that how to reduce the how to do optimization with the help of variables. It is called as variable propagation, and variable propagation will lead to dead code elimination. Means after applying variable propagation, there isn't any need of this code, that is x equals to a now not existed. Why? Because in that we only have in final statement a, b, 4 and d, right? We don't have any x here, and there isn't any use of x here. That is why in our final code we can just write it like c equals to a into b and d equals to a into b plus 4. So this code is considered as a dead code elimination, right? So variable propagation will lead to assignment statement as a dead code. So Siddhi, is it clear? Siddhi, second and third is clear to you or not? Please answer me. Is this are clear to you or not, guys? Yes, very good. So these are the 5 types of code optimization techniques I have told you with the real example, so that you can learn it betterly, right? Clear to everybody that code optimization ways are clear to everybody, guys? Please comment me. Okay, clear to everybody. Should I proceed to next topic, guys? Should I proceed to next topic? Okay. Okay, guys. So take a next heading as a where to apply optimization. Take next heading as a where to apply optimization. Then we are going to discuss some important points on it. Okay, guys. Again, focus on the screen now. Now, up till now, what we have learned, that there is a need of optimization in code, so that our performance of the code can be increased, and it is of two types, that is machine dependent code and machine independent codes, and there are various methods of optimizations, right, that we have discussed, like induction variable strength reduction, in code motion like loop optimization, in dead code elimination, variable propagation, and compile time evaluation, right? So the question now here is, now let's see where to apply this optimization. Right. So guys, this is theoretical important points which you just note for the purpose of GK, and these points may ask get from directly as a part of GK, just a theoretical question or the conceptual question, because whatever I am discussing it with you, whatever points in the code optimization I am discussing with you, all are very very important points, and GATE can directly ask theoretical questions like which of the following statements are true out of ABC, A and B, B and C, all of this or none of this, like that. So these are very very important points. Make a note of it, or if you are taking a screenshot, well and good, no problem. Okay. Arjun is asking, sir, in the new syllabus, is there only theory? Arjun, there is a local optimization technique, and there is a there are constant theories and so many. So once we are focused on the theory, after that we are going to solve questions, Arjun. Once we are okay with theory, after that we will discuss the questions, because if you will not know the basic concepts of optimization, if you will not know the basic concepts of optimization, how can I go directly to the local optimization? How can I directly go to the problems, right? So before that, there is a great need of this kind of knowledge, right? So there is a need of this kind of theory, and after that we will go on the questions, that how questions may be asked. So because it is a newly added topic, that is why there is a need to understand the basic concepts of this. After that we can go on the live examples, right? Don't worry, Arjun, we will discuss each and every topic, don't worry. Now, where to apply optimization? So on source program we can apply optimization. On source program we can apply optimization. So optimizing the source program involves making changes to the algorithm or changing the loop structure, right? So optimization in source program involves making changes to the algorithm itself or changing the loop structure. It is user is the actor here, means user will change whatever he wants to change in the code, right? So it is called as that we are applying optimization in source program. Now we can also apply optimization in intermediate code. So optimizing the intermediate code involves changing the address calculations and transforming the procedure calls involved. Here compiler is the actor. Here compiler is the actor. That is the second type of that where to apply optimization. And the next one is target code. Optimizing the target code is done by the compiler and by usage of registers, select and move instructions is a part of optimization involved in the target code, right? So they may ask directly questions in a theoretical form, that in source program user is a actor, whatever user is there, real time user is the actor here, means he will make a change in the algorithm itself. If we talk about intermediate code, compiler is the actor. Compiler will optimize the code according to its default program and library files. And in target code, using registers and various memory optimization techniques, in the target code itself, it will get more optimized by reducing somewhat times. So these are the three types of optimization where we can apply optimization. But manually, we can only optimize in source program itself, right? Now the next one is phases of optimization. So what are the phases of optimization? There are generally two phases of optimization. The very first one is global optimization. That is, transformations are applied to large program segments that includes functions, procedures and loops. So if we are applying large program segments, changes in large program segments that includes functions, procedures and loops, these are called as global optimization. And if we talk about local optimization, transformations are applied to the small blocks of statements. The local optimization is done prior to global optimization. And now we are on the point to learn the concepts of local optimization. Whatever the newly added topic is there in the compiler design are all covered under local optimization, like sub expression elimination, okay, local optimization itself, data flow analysis, and all we will gonna discuss with the help of local optimization. So these are the two phases of optimization, guys. Now we are on the level to discuss the real world of local optimization, constant propagation and common sub expression elimination, which are newly added topic in the code optimization. So guys, until now these are basically almost part of theoretical. So is it clear to everybody? Can we now move to the local optimization? Can we now move to the local optimization? If you guys have any problem until now, you can ask me, or I can move to the next topic. Is it clear to everybody whatever I have discussed in regard of the optimization as of now? Is it clear to everybody, guys? Please comment me in the chat box so that I can move forward and can discuss the local optimization techniques. Because this, until now, this were the part of theoretical, and in that also gate can ask question. Okay, Arjun is noting. Okay, is this slide you are noting, Arjun? Okay, you can note it, no problem. You can note it, Arjun, no problem. After noting, please comment me that done so that I can move forward, no problem. If other candidates also want to note, they can note and tell me that whether they are getting the concepts or not. Clear? Very good. If you guys noted it, please comment me that's a noted so that I can move to the next slide. Okay, Ashik is asking that, sir, please tell intermediate code repeat once. Okay, Ashik, focus here. In intermediate code optimization, optimizing the intermediate code basically involves changing the address calculations. Suppose you have assigned pointer that C is pointing to P, and then you can simply say that basically it simply means that you are assigning any address of C to P like that, or whatever you are doing like that, right? Suppose R to C or that. Then optimizing in such kind of calculations will be termed under we can say that termed under intermediate code. And in that, compiler will work as a actor, means we manually can't do anything. Whatever we'll do, compiler will do according to the use of library files, right? While compiling our code, we don't need to do anything. What we can manually do, we can make changes to our source program, which will be considered under source program itself. But in intermediate code, it involves changing of the address calculations, and compiler will behave as an actor, means whatever procedure, whatever calculations transformed there will done by compiler by help of its default library files, right? So this kind of addressing changes or source changes of the addressing calculations like that will be done under intermediate code, and we manually only can change in the source program. Okay, next slide is this, Arjun. Is it clear, Ashik? Ashik, you just need to know that in the first one, that is the source program, user will be acted as an actor. He can manually make changes to source program. And in intermediate code, compiler will work as a actor, means compiler with the help of library file will make changes to that. And in the last one, that is in target code, with the help of registers and like that, they will act as an actor, and they will change in the runtime as well on the compiler time. Okay. Okay, so guys, if you noted that, then please let me know so that I can move forward. After noting slide, please let me know so that I can move forward. Done? Okay. Okay. So now I am moving to the next slide. Now I am moving. Okay, Arjun, please do it fast. Do it fast, Arjun. Okay, so now the next topic is local optimization, constant propagation, and common sub-expression elimination, right? So these three topics we are going to discuss with the real-time examples directly. So the simplest form, the local optimization is called as the simplest form of optimization, right? It is the simplest form of optimization. It is the newly added topic this year in the GATE syllabus of 2021. And local optimization, it optimizes one basic block at a time. One basic block can be optimized at a time, right? No need to analyze the whole procedure body. There isn't any need to analyze the whole procedure body. One basic block will be optimized, and by one we can optimize using local optimization technique. Now some statements can be deleted, like if x equals to x plus 0 is mentioned, then we can optimize it like x equals to x, and suppose x equals to x into 1 is there, then we can simply write it like x equals to x. So it is the simplest form of optimization, and optimization is done in one block at a time, means no need to analyze whole body. And we can optimize x plus 0 as x equals to x, and we can optimize x equals to x into 1 as x. So you can observe it that very simplest form of optimization it is. Now, eliminating these instructions are great optimizations. As we are removing an entire instruction, some statements can be simplified. For example, if your statement is like x equals to x into 0, like that, then we can eliminate the entire instruction and we can rewrite it x equals to 0, because ultimately there is a need of writing in 3 address code. We can write it in 2 address code itself. So this is also called as one kind of optimization. It is the simplest form of optimization and termed as local optimization. So these are the first two very easiest example. Is it clear, guys? If you want to note it, please note it, and we will move for the next slide. Is it clear? Simplest form of optimization. It will be done one block by one block, and entire statements can be changed many times, and after that it can got simplified like that. If you guys are noting, please note it, and in comment section please comment noted so that I can move forward. Because after discussing these statements and these rules, I am giving you very important questions which you gonna need to solve. Noted? Okay, guys. So now let's come to the next slide. Another example I am presenting in front of you guys. Focus first. Completely focus on the screen, because this is very important question. Very important example I am giving you, and after that I will give question to you. So just focus here completely. Focus here completely. Right? Focus here completely. Sir, what is the need of x equals to? It's better not to write the line, isn't it, sir? In which one you are talking, Soumya? For which example you are talking, Soumya? Suppose it is 1, it is 2, and it is 3. For which example you were talking about? Please answer me. Okay, x equals to x. Yes, it should completely be eliminated. You can focus here. You can focus here. Focus Soumya here. Eliminating these instructions are great optimization, as we are removing an entire instruction. So this entire instruction can be removed. No need of this, because everybody know a equals to a. Everybody know x equals to x. We are removing entire instructions, right? So no need of write it. But this optimization will done, and after that we can we in our compile in we can okay with it, and in x equals to x and x equals to x, there isn't need of write anything, because x equals to x, it is clear to everybody. No need to write anything after that, right? No problem, no need to write it. But why we are not writing it? That is why I simplified it like that. I simplified it like that. That is why we are not writing it in optimized code. It will be considered one kind of dead statements, no problem. Okay, Soumya? Now we are focusing on the next question. Just focus completely on the screen, guys. Focus completely on the screen. Suppose our statement, our code statement is x equals to x into 8. Then we can optimize it like that. Why we are optimizing it here? Just focus here. Replace multiplication by a power of 2 to a shift left operation. This is called a shift left operation, guys. This is called a shift left operation. And in compiler, this multiplication can be replaced by power of 2 to a shift reduce operator. This is considered as a power of 2. This is considered as a power of 2 shift left operation. Power of 2 shift left operation. Power of 2 shift left operation. It is called as power of 2 shift left operation. So x equals to x into 8. We can rewrite it as a x equals to x shift left operation power of 2 and 3. Okay, so what it will do? It will simply multiply anything with 8, whatever x. Suppose the value of x is 2. Suppose value of x is 3, or suppose value of x is 10. Then this will, what it will done? It will consider 2 to the power 3 to it. It will gonna 8 with it, and 10 into 8 will gonna 80. So shift left is power of 2. It is power of 2. So whatever after this shift left reduces, it will consider it as a 2 to the power 3. So this 8 can be write like shift left operation of power of 2, and then we can rewrite it like that. So this is nothing but we can replace multiplication operator with that. Now why we are replacing multiplication operator with this shift left operation? Because this multiplication operation have higher strength and this shift left operation have lower strength. So our code will got optimized in terms of time complexity. That is why we are writing it like that. On some machines, left shift is faster than multiply, but not on all. Very, very important point. This can be asked in terms of statement, assertion and reason type question. In assertion and reason type questions, you may face this question. On some machines, left shift is faster than multiply, but not on all. And modern machines have their own rewriting logic in hardware that can deal with these special cases really fast. Okay, but as of example point of view, we can optimize this code further with this code. This both code will work with the same, but the efficiency of this code would be more. Now suppose x equals to x into 15 is there. So we can again optimize this code with the terms of time complexity. How? We can rewrite it using shift left operation, that is t equals to x shift left operation 4. So what it will do? It will, whatever is there, it will multiply it with 16. It will multiply it with 16. But if you will observe here, we only have 15. So to make it exactly like x into 15, again we have done, we have done x equals to t minus x, means it will reduce the 2 to the power 16, and then further if we will add this statement, that is t minus x, so this complete statement will work similarly as a x into 15, that is reduce that multiplication symbol by 1, that is this t, the value of this t will get reduced by 1 because here t minus x is there. So we can rewrite this code like that. Okay, so this is the another example as a local optimization, because we are doing in a block, and this is called as local optimization. So guys, is it clear to everybody? Is it clear to everybody, guys? Can I move to the next one? Is this example clear to everybody? Okay, it is clear. Very good. Now I am giving an example to you guys. I am giving you 3 minutes to solve this example. Now Arjun, you have asked me, na sir, that whether this is theoretical or theoretical. So it is the real example you may face in your GATE exam. This kind of questions 100% you can get in a exam. Basically, compiler design asks all questions around parsing and syntax directory, but as of new syllabus, that local optimization is also included. So this kind of questions you may face directly, because until now we don't have local optimization in our GATE syllabus, but now we have. So you can face this kind of questions, guys. So this is the example. Now you need to answer me. You all need to answer me. I am giving you 3 minutes. What would be the optimization code in respect of this code? What, how you will optimize this code, guys? Just use your manual power. Just apply your strategy and approach. Just apply your approach. After that, I will discuss the solution. But before that, please apply your logic that how we can reduce it. And after that, I will tell the solution. But as of now, I am giving you 3 minutes. This kind of question you may face in real GATE exam. So how this example can be transformed, how this code can be optimized, please answer me. Okay, Ashik, what is answered? Last line replacing with x into y. Okay. Okay, guys, solve it. Don't worry, I will tell you. I will tell you the answer. Don't worry, just apply your approach. No worry. You just need to do local optimization. Means in this block, whatever techniques I have discussed with you till now, you can apply that and answer me. I am giving you 1 more minute, and after that I will discuss the solution. Just 1 more minute, guys. After that I will discuss the solution. So may I answer x equals to x as 1. Okay. We're replacing in second line. Okay. Yeah, we may use that. Very good. Very good. Because guys, apply whatever techniques I have told you. Whatever techniques I have discussed with you, please apply that. Please apply that. Very good, Abhishek. Very good, Soumya. Ashik, okay. Manjit, very good. Arjun, if we can improve, please improve and verify it once again. Yes, I am observing Abhishek, Soumya, Manjit, Ashik answers correctly as of now, but I will also discuss it, don't worry. Okay, now focus on the screen, guys. Now focus on the screen. Just focus on the screen. I am discussing the solution one by one. One by one, I am discussing the solution. You have reduced it. All candidates have reduced it. But we can further reduce it. Means you have done step 1, 2, like right, but we can further reduce it, guys. How? The value of a is 5. We can directly substitute value of a here, because we can done it at the compile time execution. So I can directly write, a equals to 5 is here. So I can directly put the value of a here, which is 5, because at the compile time optimization we can do it, because we have discussed, I have discussed here, I have discussed where, here, In compile time evaluation we can directly put values. In compile time evaluation, here you can observe here, in compile time evaluation I have directly put the value 12.4 here and calculated the result, because this is one of the technique which I can do at the compile time evaluation, right? So you can apply this technique as well. There are 5 techniques, right? So 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 just focus here. X equals to 5, 2 into 5 is here, so you can just directly write x equals to 10. After that what we have, y equals to x plus 6, but we don't have the solution of x now, so in next step we will do that. And t equals to x into y we have, so we are just writing x into y as of now in next step a equals to 5 is there, x ki value we are getting 10 from here. So in next step y equals to, we can put the value of x from here. So what I will do, I will just write it like 10 plus 6 and I will got 16 here. And now I got t equals to x into y. Now I need to multiply my x with 16. So I can use shift right, shift left operation, because the strength of this multiplication symbol is higher. So t equals to x and y I write here for, because this will be considered as a power of 2. I told you now earlier, I have told you it will be considered as a power of 2. So we can directly write it like t equals to x multiply with 16, because this will be considered as 2 to the power 4, which I have already discussed with you earlier. That is why this code we can directly say that is the reduced code in terms of time complexity. Is it clear to everybody, guys? Is it clear to everybody? Because it is first question, so don't worry, all of you have applied correct approaches, but further that we can also lead it to one more step ahead, right? So I used compile time execution, and I also used simple techniques of shift left operation. Is it clear to everybody, guys? Okay, very good. Now next question is in front of you, guys. It is very important question, very important question. Please solve it again. Very important questions for local optimization topic, and you may face similar kind of questions in gate. Whatever I have discussed earlier, this kind of question, whatever I am discussing in this slide, this kind of question, it is very easier question. You just need to know the theoretical concepts. If you know the theoretical concepts or conceptual concept of that, you can directly answer me. Very easiest kind of questions. Answer me that out of A, B, C, D, which of the following option is correct? I am giving you 2 minutes, guys, to answer this question. Just apply the knowledge which I have discussed with you in earlier slides. And answer me that out of A, B, C, and D, which of the following is the correct answer? Completely focus on the question, guys. Only one option is correct. Out of A, B, C, and D, only one option is correct. Only one option is correct. And why one option is correct? You will get its answer in question itself. In question itself, you will get the answer. So only one option is correct out of A, B, C, and D. Please answer me, guys. Please verify the answers once again. I am giving 1 more minute, and after that I will discuss the solution, guys. Okay, I got so many answers. Requesting other candidates as well that, guys, please be interactive with us. Please answer all the questions so that your practice can be happen simultaneously in our classroom section, and we can cover all the topics, right? Okay, guys, very good. Now I am solving the question. Just focus here. The question is, in compiler optimization, operator strength reduces Reduction, operator strength reduction uses mathematical identities to replace slow math operation with faster operation. Which of the following code replacement is an illustration of operator strength reduction? Right? So option A, just focus on the screen guys, focus on the screen. Each and every doubt will be clear to you. Each and every doubt will be clear to you. Please focus on the screen. P plus P, if we will reduce it with 2 into P, so this will going to not optimize our code. This will going to further lengthier our code, because multiplication will take much lengthier time, because the strength of this multiplication operator is higher and strength of this plus addition operator is lower. So P plus P would be done as a code optimization technique, because this is our low strength operator. So why we will go for that? So this is incorrect. Option A is incorrect. Is it clear to everybody or not? However, 3 plus 4 we can replace with 7, but this statement is incorrect. Is it clear? Now focus on statement B. P into 32 we can replace it with left shift operator, left shift power of 2 operator. So it is nothing but P into 32, because this will work as a 2 to the power 5 and will result in same, but the strength of this operator is somewhat lower than that. So option B is correct. Now some candidates are asking why option C is not correct. P into 0, if we will replace it with 0, okay, it is correct. We are optimizing this one, correct, but we need to answer in terms of mathematical identities to replace slow math operation with faster operation. We need to answer in terms of this. We need to answer our question in terms of this. And in terms of this, B option is most accurate. We will treat B option as the most accurate, because we need to answer according to the question. However, it is also code optimization technique, and this is also code optimization technique. This is also code optimization. This is also code optimization. This is also code optimization, and this is also code optimization. But if you will focus on the question is which of the following code replacement is an illustration of operator strength reduction? Which of the following code is the replacement? Which of the following code replacement is an illustration of operator strength reduction? We need to answer according to this. That is why option B is correct. Is it clear to everybody? Is it clear to everybody? Please answer me. Is this that why option B is correct? Is it clear to everybody? Clear na? Option B is correct, because option C is correct, but we are not working according to operator strength reduction. And in option D, if you will observe, if we will replace this with this, our code optimization will get lengthier. Why we will replace this with this? It is the reverse technique we are doing. We do not need to do this, and we also do not need to do this, because we need to answer according to operator strength reduction. So most accurate answer is option B. Soumya, option D is not correct, because we will reduce P into 15 for this. Why we will optimize this into this? This is not an optimization technique na. This is not an optimization technique. Is it clear, Soumya? This is not an optimization technique. We will write P into 15 as a P less than 4 minus P. But why we will write it like it? It is the reverse technique na. That is why option D is correct. Okay, everybody got it? Okay, candidates are asking for break. Are you guys needed break, guys? Okay guys, so the next question is in front of you, and you may face similar kind of question in your GATE exam as well, guys. In similar kind of question in your GATE exam as well. Very important. I will mark it 5-star, guys. Very important. From local optimization, constant propagation, common sub expression elimination, All these concepts will get clear to you with this single example. With this single example you will get to clear all these concepts, that is local optimization, constant propagation, and common sub expression elimination. You need to assume that only f and g are used in the rest of program. With this hint in the program, you can answer the question. I am giving you 5 minutes, guys. It will take analysis on the question, and whatever we have discussed yet, you can apply all the approaches, and then I will discuss the solution step by step, guys. Step by step I will discuss the solution. But whatever the approaches I have discussed to you yet, please apply the approaches and strategies and solve this question, and answer me that what is the final code after optimizing this code. After optimizing, what you are getting, guys. Apply all the techniques which I have discussed with you. Let us focus on the solution of this problem now. See here, this is our algebraic simplification. Algebraic means you can consider it as a step one. Guys, focus on the screen, and one by one, step by step, we are going to solve it. Step by step, we are going to solve it. Step by step. Focus. Initial code was this. So this code is simply the algebraic simplification, means we just need to write in the simplest form of algebra. So a equals to x into 2. This can simply be written like a equals to x into x. This can simply be written like, it simply means that we are multiplying x with x. Means x is the power of x power 2. So this can be simply written as x into x. Right? And as I already told you that b into 2 is there, so you can apply shift left operator here. You can apply shift left operator here. One by one we need to do it manually. So what I did in this step, I on the place of this multiplication, I use shift left operation and replace this as a 1, because this completely will give me the value 2 to the power 1, that is 2. So ultimately it is nothing but b into 2. Okay, so in the easiest step, that is the first step, I did algebraic simplification. What I did, algebraic simplification. Now in step 2, that is in next step, what I am doing, I am copy the constant propagation. Whatever constant propagation are there, I am copying them. So focus, this is the constant propagation, that is b equals to 3. It is my constant propagation. It is my constant propagation. So in constant propagation, I am copying this, and c equals to x. It is also my one of the constant propagation. Okay, and these two are now same, but in next step, that is in copy and constant propagation, what I am doing here, c into c is there, so I am copying the constant propagation. I am replacing this c with x and x. I am replacing this step with this step. You can observe in step 3, which is a part of step 2, but in this block I just told you what I am doing. So b equals to 3 was there, so initially I put b equals to 3, which is as it is remained same. C equals to x is there, so this left hand side is c, this on the right hand side x was there, so they are getting replaced with c, because ultimately this c is holding the value of this x, this c is holding value of x. So what is the need of this statement now? We can directly replace it with c, with x. So I replace this with x, so no need of c now. And here b was there, So on the place of this b, I replace this b with the value of b. What is the value of b? 3. So I replaced this b with the value of b here, that is 3. So it is called as constant propagation. This is called as constant propagation, means whenever we are playing with the constants and replacing the variables value or the constants value in the next transition, that is b equals to 3 was there, so there is a on right hand side b was there. So if on right hand side b is there, that is on right hand side a constant is there, and if we have value of that constant, and if we will replace the constant with its value, it is called as constant propagation. And if we replace it with the variable, here this c is replaced with this x, it is called as variable propagation, because we are replacing this c with the variable x. It is called as variable propagation, which I have discussed with you earlier as well. And in this step we have replaced this b with the value of b is a constant, and we are replacing this b with the value of b. That is why it is called as constant propagation. So what we did, we just copied the value of b here. In next step, after doing copy and constant propagation, our equation is looking like that. This is the same step of this, right? This is the same step, whatever step this, I just copied it here. This is the same step. Now next is called as constant folding. The next step is called as constant folding. In constant folding, what I need to do, in constant folding what I need to do, I need to evaluate the value of constant. In constant folding, what I need to do, I need to evaluate the value of constants. So I can easily evaluate the value of this constant. This shift left parser what tell me, 3, it is a power of 2, multiply with 2 to the power 1, that is 3 into 2. So I can directly replace it with 6. So the value of e is replaced with 6 here. It is the output of constant folding. It is called as constant folding. So step by step we are doing. In step 1 we did algebraic simplification. In step 2 we did variable propagation and constant propagation. In step 3 we did constant folding. That is, we replace the value of e shift left operation 1 as a 6, because it can be written like that. Now I am copying this step again. This step is simply copied it here. It is the same step. It is the same step, right? This step is copied here. Now the next step is common sub expression elimination. That is this common sub expression elimination. In common sub expression elimination, what we are doing? Observe here. Observe here. As of the grammar, we have a equals to x into x here, and we have d equals to x into x here. So if you will observe here, a equals to x into x is here, and again we have d equals to x into x here. So we can reduce this 3 address code. We can reduce this 3 address code to 2 address code. So we can replace this x into x with the result of a. Whatever the result a will stored, the result of x into x will be stored in this a. So whatever result this a is storing, whatever result this a is storing will be passed directly to the x into x. So I can directly write d equals to a, because x into x is nothing but the result of it is in the hold of a. So I had write d equals to a. So what I did in here, I eliminated the common sub expression, because x into x and again x into x, these both are common sub expressions. So what I did, I eliminated these sub expressions. I eliminated these common sub expressions. So after eliminating common sub expression, my code, my optimized code would be look like that. Now I again need to focus that where I can further make optimization. So I am copying this code. I am copying this code here. So this is the exact code after elimination of the common sub expression. After elimination of the common sub expression, my block is like this. Now if you will again observe here, the next is again copy the constant propagation, because again I have d equals to a here, and again I have e equals to 6 here. So you can see here that I have a plus d here, a plus d. So I can replace this d with this a, because whatever on the right hand side is there, d is holding value of that. So I can directly replace this d with a, no need to take further value of d, because my goal is to reduce what is my aim? The aim of optimization is reduce the number of lines in code. So it is my ultimate goal. The aim of my ultimate aim is to reduce the number of lines in code. That is why whatever is existed on the left hand side, if it can be reduced on the right hand side, that would be better. So d is here on the left hand side and d is here on the right hand side, so I can replace this d with a. So I replaced this d with a here. So it is what I did. It is called as variable propagation or copy and constant propagation. And here value of e is 6, so I can replace this e as a 6 here. It is called as constant propagation. Whenever we are putting the value of constant, it is called as simple constant propagation. Just put the value of constant into the whatever we have in the grammar as a variable. So I just put 6 on the place of e. Now my optimized code, after applying constant and constant copy propagation again, that is after applying constant propagation and variable propagation, now my code is looking like that. Now again I am copying this code here. So this is my code here, this is my code here. Now if you will observe guys, if you will observe, now I will remove the dead code here. Now I will remove the dead code here. So you can easily say a equals to x into x is here, b equals to 3 is here, c equals to x is here, d equals to a is here, e equals to 6 is here, f equals to a plus a is here, and g equals to 6 into f is here. Like that, after applying this variable and constant propagation, I am getting this step. Now if you will observe here, my first code is a equals to x into x, okay. My next code is f equals to a plus a, okay. My next code is g equals to 6 into f. So my final step is 6 into f. My final step is this. Before that I need value of a, and in that I need value of a. So these 4 steps, it is called as dead code. It is called as dead code because I don't have any need of this now. I replaced it, I reduced my code, I optimized my code. So after eliminating dead code, final grammar I am getting is a equals to x into x, f equals to a plus a, and g equals to 6 into f. This is the question after eliminating that code. So guys, this is the real problem of GATE you may face, because this is the hardest level problem in GATE. If they want to ask, basically if you all know the GATE perspective, 40% problems are easiest level, next 40% problems are on moderate level, and 20% problem are hardest level. Basically in 65, GATE have 65 questions. In that 65 questions, they mix all the questions with the combination of 40% problem as the easiest problem, 40% problem is a moderate level problem, and 20% problem is a highest level problem. So in that highest level problem you can face that question because it is newly added topic, and this is the answer, this is the final code after optimize, or you can, or I can say this is my optimized code. Oh, Manjit is asking, sir, can you explain it again? Okay, Manjit, don't worry. I will explain it again. Don't worry. Arjun is asking, sir, but we will not use A in further code. So why not replace it to in F? If I will replace this F, A plus A in F, if I will replace it with A plus A, it will not be 3 address code. By default our machine is processing 3 address code. By default our machine is processing 3 address code. That is why these all are the forms of 3 address code by default, because 3 address code is globally accepted. It is globally accepted. 3 address code is globally accepted, means in every machine, whether you are using Linux, whatever your operating system is iOS, whatever your operating system is Windows, or whatever your compiler design and configuration is there, 3 address code is globally accepted. So our focus will be on that. Our code should not exist 3 address code properties. Okay, Arjun, that is why we didn't replace, because we again replace this a with x into x into a. Again we can replace f and we can make into single line. But our target is make it in 3 address code. So whenever I will give you problem or you will face this kind of problem, try to answer it in 3 address code format. Okay. Okay, Manjit is asking for once more. Okay, Manjit, I am discussing it once more. I am discussing it once more. Don't worry. I am discussing it once more. Focus here. If all the candidates who haven't got the answer, who haven't got the concept, again focus here guys. I am discussing and I am repeating it again. Please focus here so that nobody can leave with any kind of doubt or query. So it was my initial code. It was my initial code. Now this initial code in step 1, what I will do, I will form it into the algebraic simplification. A equals to x into 2. It simply means that I am multiplying x twicely. I am multiplying x with x. So I can simply write it as a x into x. So I replace this a like that here. Remaining b equals to 3. It is remaining same here. C equals to x remaining same here. D equals to c into c remaining same here. But b into 2, I am replacing it as a shift left operator, because b shift left operator 1, it will output me b into 2. So I can replace b into 2 with the help of shift left operator, because the strength of shift left operator is lower than multiplication. So I can write it like this. After algebraic simplification, I am going to copy and constant propagation. In copy and constant propagation, if you will observe, b equals to 3 is my constant and c equals to x my constant. So I will replace this value of b here and I will replace this c with this x. So in this step, what I did, a equals to x into x is remaining same, and whatever the value of b is there, I replace the value of b with here, because the value of e is b shift left reduce and 1. So I replace the value of this constant b with 3. So it is now 3 shift left operator 1, and I replace this c with the variable x. It is called as variable propagation, like d equals to x into x. So it is my next step after applying variable propagation and constant propagation. Now I will copy this code similarly here. This is the same code which I got directly from here, and now I will apply constant folding. What constant folding basically means, whenever we have such kind of operations like shift left reducer, shift left operator, I will directly replace it with its result. What result it will hold? 3 into 2 to the power 1. It simply means that like that, because it is a shift left reducer. It simply means that power of 2 into whatever we have on the right hand side will be on the power of 2. It is simply means that 6. So I replace the value of e as a 6 here, and all the remaining statements are same in constant folding. So in constant folding I will do such kind of operations. Now I will copy the same code I have copied here. This is the same code. Now I am doing common sub expression elimination. In common sub expression elimination, what I am doing here, I am finding that I have d equals to x into x and a equals to x into x. These are my common sub expressions. So I can replace this common sub expression. I can replace this x into x with a. So what I did, I replaced the d equals to x into x with d equals to a, because a equals to x into x. I replaced it. It is called as common sub expression elimination. And after eliminating common sub expression elimination, I got this code. This is the code, which is the output after common sub expression elimination, because here I got this x into x and x into x as a sub expression. I eliminated this, and after elimination I got this code. Now I will copy this code here. After common sub expression I got this. Now I will again apply copy and constant propagation, that is variable propagation and constant propagation I will again apply here. You can observe here in this code, this d can be replaced with a, this d can be replaced with this a, and the value of this a can be replaced with this 6. So in copy and constant propagation, I replaced this d with a like this. I replaced this e with the value of e, that is 6, and I replaced it in my next step. So my code is now looking like this. This is my code. After copy and constant propagation, I got this. Okay, now I will copy this. And after copy, I copied it here. Now dead code elimination would be there. Dead code elimination is the elimination of the code which is not required in our next phase. So in next phase we are only remaining with a equals to x into x, f equals to a plus a, and g equals to 6 into f. There isn't any further need of b, c, d and e. So we will eliminate all this. After elimination our code is optimized like this. So our this code is optimized to this code. So this is the problem you may face in real GATE exam. This is the you can say most expected problem under code optimization and newly added subject. So whatever they have added as a newly added syllabus in compiler design, this is the only problem you will face, because we don't have further problems in it. All is the theory. This is the only problem you will face, because this problem consists of the knowledge of all topics. Is it clear to everybody? Guys? Tell me, is it clear to everybody? If anybody have any kind of doubt, please comment me. Sir, can we, okay, Shivang is asking one question. Sir, can we not directly put b equals to 3 in E equals to E into f? No. Because if we will put, if I will replace it, I will not get the correct code after that. Why I will not get? Because in this code, after application of this, I will not gonna face this problem, because I need to take at least a, f, g. I need to take the value of a, f, g, because in my problem statement itself it is given that assume that only f and g are used in the rest of the program. Assume that only f and g are used in the rest of program. That is why I can't replace it. It is okay, Shivang? Is it okay? Okay, it is clear to everybody. Very good, guys. Very good. It is clear to everybody. Good, guys. Now I am moving to the last topic of compiler design, that is data flow and liveliness analysis of compiler. So guys, it is completely theoretical. Whatever you question you may get, you will get from here. Now just discuss some important points so that we can complete the compiler design syllabus. The first point is, it is the analysis of flow of data. In control flow graph. That is the analysis that determines the information regarding the definition and use of data in program. We will discuss it with the example, because it is completely theoretical topic, guys. With the help of this analysis optimization can be done. And it is the analysis of flow of data in control flow graph. In general, it is a process in which values are computed using data flow analysis. Using the value of data flow analysis, we can compute the values. And the data flow properties represents information which can be used for optimization. The data flow properties can be represent information which can be used for data optimization. These are the theoretical points. Just make a screenshot of it, because completely theoretical, no need to answer, and it is not a weighted topic according to GATE. Just focusing here as the syllabus of GATE, you will get question directly like this kind of question. This is important part of GATE. This is just theoretical, but take a screenshot. Just take a screenshot, and we will move to the next slide, because you will get clarity with the next slide. So the next slide is basic terminologies in data flow analysis and liveliness analysis. So definition point is there. The basic terminologies in this definition point is a point in a program which contains some definition. A point in a program that contains a definition is called as definition point. A reference point, a point in a program that contains a reference to a data item, it is called as reference point. An evaluation point, a point in a program that contains evaluation of expression, it is called as evaluation point. What it is, let it understand with the data flow and liveliness analysis. Suppose it is my control flow, suppose it is my control flow. Then here what I did, I described the value of a equals to 2. It is my definition point. Again read the definition. A point in a program, a point in a program that contains some definition. So this point contains some definition, that is why this point is called as definition point. Next is reference point, a point in a program containing a reference to a data item. So this point is contain a reference to a data item b. B is referencing the value of a. So according to the definition, a point in a program that contains reference to a data item, this b is contains reference to a, that is why it is called as reference point. And the last one, that is evaluation point. Evaluation point is a point in a program that contains evaluation of an expression. So here we are evaluating the value of z equals to x into y, or whatever we will evaluate here, will be considered under evaluation point, So with the help of liveliness analysis and control flow, you can understand that whether it will help. Basically it is a subjective topic, no relation with GATE, but yeah, GATE added in the latest syllabus. That is why we are discussing the theoretical points in it. I hope you are getting the concepts of basic terminologies, guys. Now data flow properties. There are some important properties of data flow you must know, because you may get this kind of question as directly theoretical question. So for that purpose we are discussing the basic terminologies in it. The first one is available expression. What is available expression? A expression is said to be available at a program point x if and only if along paths it's reaching to x, a expression is available at its evaluation point. Basically, a expression a plus b is said to be available if none of the operands get modified before their use. You can understand betterly directly from this. Suppose at b1 block we have L1 equals to 4 into 1. At b2 block y equals to x plus d into L1, means we are fetching the value of L1 here. And in L2 we are having directly taking value of 4 into I. So expression 4 into I is available for block B2 and B3, sorry, because in B2 and B3 this is the block. So basically we will say that B1 is available for B2 and B3. So in this, what is available expression, guys? Available expression is an expression which is said to be available at a program point x if and only if along the path it's reaching to x. A expression is available at its evaluation point. Means at B2 this is available, at B3 this is available. So we will say expression 4 into I is available for block B2 and B3. Now advantage, what is advantages of it? Advantage of available expression is it is used to eliminate common sub expressions. To eliminate common sub expressions, we will use available expression. Arjun, it is completely theoretical, no logic is there, completely theoretical topic. Just make a definition and understand with the help of graph. If you have a value at b1 block, suppose a, and if this value of a is available to b and c without modified, for example, understand from here, a equals to b plus c. Here I am using value of L equals to b plus c. Here I am getting value of m equals to a plus c. And suppose in next block I am using z x equals to m plus y, or suppose m plus l. Then I will say regarding available expression, that available expression a is available in m, because I am directly using the value of a. but this available expression is not available in this because I don't have a value in it, and I also don't have available expression in, suppose it is block 1, it is block 2, it is block 3, and it is block 4. So in block 3 only I have available expression A. In block B2 and B4 I don't have available expression. Why? Because I don't have availability of A here. And here you will say, sir, in M we have A, but what, according to the definition, the expression is available at its evaluation point, it's said to be available at a program point x if and only if it is reaching to x. A expression A plus B is said to be available if none of the operands get modified before their use. So here if you will see, value of A is modified, it is added with the C and then M came. So A is only available to B3, it is not available to B2 and B4. Guys, are you getting the what available expression means? Are you getting it or not? Understood? Very good, guys, very good. Now the next one is reaching definition. It is basic what I am discussing with you. Analysis properties. Analysis properties. The first property is available expression. The second property is reaching definition. What reaching definition means? It means that a definition D is reaches a point X if there is a path from D to X in which D is not killed, that is not redefined. For example, B1 consists this definition, B2 consists this one, B3 consists this one. So if you will observe, D1 equals to X plus 4. So we will say that D1 is reaching definition for B2, but it is not reaching for B3 since it is killed by D2. Why? Because the value of this X equals to 4, we will use value of X equals to 4 here, but now the value of X is getting changed to 6. So the value of this X is only reachable to B2 only. This is not reachable to B3. Why? Because in B3 this X will hold the value 6, not 4. That is why D1 is reachable only to B2, not to D3. Is it clear? Is it clear that what reaching definition is, guys? Is it clear what reaching definition is? Ashik is asking for previous slide. This is the previous slide, Ashik. Actually, these all are the definition point of view. Completely theoretical, but you need to know the concepts, because if you will know the concepts and if direct conceptual question may ask, you can answer. So reaching definition is the definition in which a definition D is reaches to a point X if there is a path from D to X in which D is not get killed. And what are the advantages of it? The advantages of it is it is used in constants and variable propagation. It is used in constant, this X is a constant, and variable, whatever variable we have, so it is only used in constants and variable. That is why we will say it is a reaching definition, guys. It is a reaching definition. And the last one is live variable, live analysis. What is live variable? A variable is said to be live at some point P if from P to end of the variable is used before it is redefined, else it becomes dead. For example, focus on this chart, guys. Focus on this chart. Focus on this chart. Suppose A equals to 4 is here, which is defined in block B1. C equals to 7 is here, which is defined in block B2. B equals to 5 here, which is defined in block B3. U is here, which is defining A plus B in block B4. And A equals to C plus U, which is defined in B5. Now we will say A is live at B1, B3, B4. Means this A is live in B1, that is in B1 it is live, we have value of it. In B3 we have live because we have directly reachability of A here. In B4, in B3 we have, in B3 where is it is B3, in B3 we have, and in B4 we have live variable. Why? Because we have availability of A here, this A is existed here. But in B5 this A is got killed. Why? Because it is redefined. A equals to C plus U. Here A is defined as A equals to 4, but here A is redefined as A equals to C plus U. So here we have redefined. So whenever we will redefine it, we will say live variable is killed. That is why A is live only at B1, B3 and B4, but it is got killed at B4. Is it clear, guys? Comment me in the chat box. And the advantages of live variables are, it is useful for register allocation and it is used for dead code elimination. it is the last topic of today's. Is it clear, guys? What is live variable is? What is live variable is? It is clear to all of you. Due to time shortness, I am discussing it fastly. Okay. Okay, Soumya. Should I discuss live variable once again? Should I discuss live variable once again, guys? Soumya, should I discuss live variable once again? Okay. So live variable, according to the definition, it is a variable is said to be live at some point P if from P to N of that variable it is used before redefined. So here it is live. Why it is live? Because A have direct reachability to B2. This B1 have direct reachability to B2. That is why we will say that it is a live variable for B2. For B3, B1 is have direct reachability. That is why we will say it is live at here. In B4, we are using A, directly reachability of A. That is why we will say live. But in B5, we are redefining A equals to 4 here, but we are again redefining A with C plus U. That is why I will say it is not live variable for B5. For B5, it is got killed. Is it clear now, guys? Is it clear? Yes, Ashik, we can say live variable is related to the scope of variable in a transition, we can say. But scope is not a correct suitable term here. Scope will not be a suitable term here. But according to the concept that you have applied, it is the correct answer. Correct strategy you are applying. Is it clear to everybody now? Is it clear to everybody? Okay, guys. So the last slide of today is busy expression. An expression is said to be busy along a path if and only if its evaluation exists along that path and none of its operand defined exists before its evaluation along that path. The advantage of busy expression is it is used for performing chord movement optimization. Means busy expression is busy along its paths if and only if its evaluation exists along that path and none of its operand definition exists before its evaluation along that path. For example, we will say just 2 seconds. Busy expression is an expression which is busy along a path if and only if its evaluation exists along that path and none of its operand definition existed before its evaluation along that path. If you will observe here, this B1 is can be said as a busy expression because before it we don't have any definition of. This C equals to 7, it is called as busy expression because before that we don't have any definition of B2, that is C. For B equals to 5, we will say that it is a busy expression because before that we don't have any expression of that. In B4 U equals to A plus B, this is not called as a busy expression because we have defined A earlier and we have already defined B earlier. According to the definition, none of its operand defined exists before its evaluation along the path. So B1, B2 and B3 are busy expression, but B4 and B5 are not busy expression. Is it clear, guys? And why it is used? It is used for performing chord movement optimization. Is it clear to everybody, guys? That what are basically these are the data flow analysis and liveliness flow properties. The first one was available expression, the second one was reaching definition, the third one was live variable, and last one was busy expression. But it is only theoretical point, just not these points because we don't have any of question in gate as of now. Theoretical concepts, subjective concepts. If gate will ask any question, the most expected question that gate may ask is directly from the local optimization, constant optimization and common sub expression elimination, because the focus of gate is completely revolved around conceptual question in which you can apply your analysis. Gate asks all question in which you need to apply your analytical thinking. So for the perspective of analytical thinking, it is important. If you are not applying your analytical thinking, gate will not ask that what is the capital of India, that is Delhi. It will not ask such kind of question. It will ask if it is capital of India, why it is capital of India. means you need to apply some analytical thinking over that, and this concept, that is local optimization, constant propagation and common sub expression, this is a part of code optimization, and in that you will get clear with all this kind of doubts. So it is most expected question of gate 2021, because newly added subject under newly added topic under code optimization, and have all the concepts like analytical thinking, reasoning, aptitude as well. So just get focus around it and solve most problem, like how to optimize code. Is it clear to everybody, guys? Yes, guys. So now we have